0.5, for example. I want to know the percent abundances. In this case, what you would do, because let's say this is X percent and this is Y percent, for example, X plus Y must equal what number? 100. Because the sum of the percent abundances must always equal 100. So you're really going to have two equations. This is one equation here on the bottom, and then you'll have the equation up here at the top. So how would you set this up mathematically? The atomic number, 10.5, which should be given in this kind of problem, will equal, now the percent abundance of the first one, X divided by 100 to change it to a fraction, times 10.1, isotopic mass, plus the second one, which is Y, divided by 100 times, in our case, 10.9. And what I would do to make this easier, this is just X over 100 times 10.1, plus what I would do is I would just change this to, this is 100 minus X over 100 times 10.9. So notice that we only have one variable now because I made this substitution of this equation in right here. Because I made that substitution, we only have one variable now, X. You solve for X and you'll have your percent abundance. So if you're asked for that kind of percent abundance, that's how I would solve for it. The rest involve much less algebra. The rest, other kinds of questions where we would give you all these numbers and ask for the atomic number, or we give you every single number and ask for one of the isotopic masses. Those would be the three variants on this kind of problem. Okay? So if you look through the practice test and do one of each, you should be set. Okay. Okay. Should we end and go to general questions, or do you want to still do combustion? You're excited. Some people are excited about combustion. For some reason. We want to balance combustion too. Is that exciting for you? Okay. You want a hard one? Okay. All right, write the reaction and balance. So I'll start writing out the reaction and balance, but if you want to work ahead and not look to see what I'm doing, you can go ahead and do that. I'll just do it silently to myself. Okay? So, but you should be able to write the reaction and balance it all by yourself, just like with a double replacement or a single replacement and those other ones. Okay. When you're done, look up and you can tell me if you're right or I'm right or neither or whatever. That's right. This is just combustion and balancing. Then you could have a combustion analysis problem. In a combustion analysis problem, what they would ask you is for an empirical formula. Now, unfortunately, I already gave you the modules, so that's not going to make a lot of sense. But they're asking you for this formula. So let's set up how that would look if we had an empirical formula problem. This would actually be written as like CXHYOZ, like that. If it was that kind of problem. We wouldn't be able to balance it yet. And here's what would be the givens. I'll have you the givens in blue. We'd have the mass of this original one. We'd have the mass of CO2, and you'd be given the mass of H2O. Okay, so all those masses would be given. You'd also have what's called the molecular mass of this compound given in U or in like AMU or sometimes in grams per mole. So in this case, what's 8 times 12 is 96. What's 96 plus 18? 114? 96 plus 18, 114. Okay, 114 plus 16, 130? Okay, so for this molecule it'll be 130. Okay? Except remember, we wouldn't know what it is yet. We just know X, Y, Z. We know the mass of it. We know this mass and this mass. Okay, what do you do in this case? Remember the key unit for empirical formula. So if we're asking for empirical formula, the key unit is what? Moles. And so for carbon, you can start off there. You'd say the mass of CO2 given. And then you change this to moles. Using the molar mass of CO2, 44.01, from the periodic table. And you say 1 mole of carbon for every 1 mole of CO2. We need to do this in this case because we have CO2 and we want carbon. So this will happen sometime whenever you have the moles of like CO2 or O2 or some sort of molecule, H2O, whatever it is, and you need to convert just to the atom, which we need in this case. This is going to be X. Then you'll do the same thing now for hydrogen. Let's get a different color. Hydrogen, you're going to go the mass of H2O. And the molar mass, 18.02, I think, grams per mole. And then there's 2 moles of H for every 1 mole of H2O, meaning there's 2 hydrogen atoms in every H2O molecule. This is going to be Y. So now we have we have X and Y. To get Z, which remember there's not always oxygen in your original molecule. There is sometimes. In the case where there is, then you have to do the following. Let's get a different color. Oh, I'm going to run out of colors. Okay. I would need to change this. Remember, this is the moles of carbon, and this is the moles of hydrogen. I would need to take one more step here and change this to grams. 12.0 grams per mole. And then I would need to change this to grams as well. So this would be 1.008 grams per mole. And so I would change both of those now to grams. Why would I do that? Because to find oxygen, I need the mass of hydrogen, I need the mass of carbon, and then I can use this following formula. I'll just write in blue as well. The mass, I'll call this mass total, just for lack of a better term, the big molecule. Mass total is the mass of carbon, which I just found up here, plus the mass of hydrogen, plus the mass of oxygen, just to clarify. This is going to be the mass of carbon, and this is going to be the mass of hydrogen. So once I make this conversion to grams, I have the mass of carbon. Once I make the conversion to grams here from Y, I have the mass of hydrogen. The mass of carbon is known, mass of hydrogen will be known, and total mass will be given. I want to find the mass of oxygen. Once I find the mass of oxygen, remember my Q unit is moles, so I'm going to go moles and then 16.00 grams per mole. And this will give me the moles of oxygen, which is Z. What do I do after I find X, Y, and Z for this molecule up here? I'm almost done. I'm going to divide by the smallest number to change it mathematically into whole numbers. Because according to the law of multiple proportions, this has to be whole numbers, X, Y, and Z. Small whole number ratios. And that would get me to my final answer. Okay, so make sure you do some practice of this by yourself with your calculator. Make sure you can do it. All right, I think what we're going to do now, because I went over everything, just as a cursory, we have some examples too. We're going to transition now. Whoever wants to go is fine. We're going to transition to our next part though. Take care of those who want to go. Specific questions. And I know specific questions annoy some of you because you hate listening to other people. So you people can go, because I'd hate for you to be annoyed. Go watch the TV and stuff. The rest of you, can you stay with you where you are or come down closer to the front? And I'll just take your questions one at a time. Get ready.